Ladies and gentlemen, welcome back to week 4, day 2 of Da Vinci Tree Online Learning. My name is Mr. Roll, and I am joined by the fantastic Miss Frusty. Oh, it's alliteration. The fantastic Miss Frusty. Miss Frusty, everybody. Today I think that Miss Lee's going to show us something. Do you remember what that was all about?
I don't remember. Why don't we go to her so she can tell us all about it?
Sounds good. Take it away, Miss Lee. That was really interesting. I don't know, what do you think?
It's pretty great.
Yeah, pretty great. Okay, well, thank you for that, Miss Lee. All right, Miss Frusty, you ready with your joke?
I am.
All right, let's do it.
What do you call a dog with no legs?
I don't know, Miss Frusty, what do you call a dog with no legs?
Doesn't matter, he's not coming anyway.
It's so dark, I love it. Okay, all right. Ladies and gentlemen, let's get ready for the Pledge of Allegiance. If you'd please stand at attention, take it away, Miss Frusty.
Stand at attention, please take off your hats and hoodies, face the flag nearest you or the one on the screen. Follow along with your right hand over your heart. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you very much, Miss Frusty. Poor dog. Hey. All right, let's go ahead and get to our work today, kids. Again, have a great day of online school. We'll see you on the internet. Bye. Oh, let's make this go away. All right, so ladies and gentlemen, welcome back. Today is week number 4, day number 2. Let's go ahead and go over today's agenda. Oop, wrong way. There we go. So today in life skills, we're going to be talking about the terms equity and mortgage, and talking about the importance of an investment as a home for one day when you're an adult. In social studies, we're going to be discussing reasons why the current recession that we find ourselves in might be a quicker one, and we might be recovering faster. Then tomorrow we're going to be talking about why we might even be recovering slower. So we're going to cover both bases. After that, we have history. We're going to be talking about the Second Industrial Revolution. In literature, you were supposed to read chapter 2 last night, so we're going to review that and then go on to chapter 3. In science, we're going to be doing a little bit of reading together and then answering these 3 questions. In math, group 1, we are moving on to finding the volume of prisms and cylinders. And then group 2, we are working with systems of inequalities. So that's what's on the docket for today. I'm going to go ahead and stop the video here and cut to our life skills. All right, ladies and gentlemen, welcome to Life Skills. We are in week number 4, day number 2. Okay, and so during this set of life skills, we're talking about 3 big investments for life. Life skills class is basically just the random stuff that I choose to talk to you kids about that I think will be useful at some point in your future one day. Okay, and so we are talking about 3 different things that you should invest in over the course of your life. The first big thing that we're going to be talking about for the rest of week 4 is investing in a house. Okay, I know a couple of your families just this year were able to buy houses, which is super cool. But before we go any further, we are talking about the benefits of purchasing and owning your own home. Okay, whether that's buying an apartment, buying a condominium, or buying a single family house. Okay, but before we get into it, it needs to be said that knowledge is power, and it can be used in many different ways. Okay, I want you to use the knowledge from these life skills classes in a way that would benefit your life. I don't want you to use this information to make anyone in your life feel bad. So, for instance, specifically talking about your parents and guardians, okay? Your parents and guardians are doing the best job that they can to take care of you and to raise you. And if for whatever reason they have not chosen to, or they have not had the opportunity to purchase their own home, it's not something that I want to hear any of you using against them and making fun of them or making them feel bad or feel less. Nothing that we discuss in life skills is intended to make anybody feel less, okay? These are just important strategies that I think that you should know and take forward in your life. And so again, if I hear about any of you using any of the things that we discuss in life skills to make your parents or guardians feel bad, you are going to be in trouble with me, okay? This information is here for your benefit. It is meant to help. It is not meant to hurt, okay? All right, so today we are talking about, or this week we are talking about buying a house. Buying a house, okay? All right, and so the first question that we should address is why? Why should you buy a house, okay? So let's do some really, really simple math, okay? Let's say that when you grow up, you grow up and maybe you're 18 and you decide it's time to move out of the house, okay? And so you move out from your parents' or your guardian's place, you're 18, you're feeling great, you're independent, and you find a nice apartment, and that apartment's rent is $1,000 per month, okay? So this is your rent at your first apartment, and it's $1,000 per month, okay? All right, now it's easy math, okay? At $1,000 per month, every year you're going to be spending $12,000 per year, okay? $12,000 per year for your apartment's rent, okay? Now, these numbers are pretty realistic. In most places in Tucson, where most of us live, Tucson can be quite a bit cheaper than other places where you might find a place to live. But in most of the United States and the rest of the world, $1,000 a month for rent for an apartment is pretty okay. You know, that's actually a number that you can expect to pay. If you live in a big city like New York, you can probably expect to pay $3,000 to $5,000 a month for an apartment. If you live in a place like Tucson, maybe you can find a place for as little as $600 a month. Okay, but $1,000 is a pretty realistic number. Okay. Regardless, at the end of the year, you are out $12,000. Okay, these are $12,000 that you're never, ever going to see again. Okay, so let's talk about buying a house. So when you buy a house, when you buy a house, you typically don't come in like Scrooge McDuck from DuckTales and just have a big like briefcase full of cash and you just lay it on the table and you open it up. Here you go. Here's all your money. You usually don't do that. You don't walk in with like a bag of gold and just set it on the table. Okay? You usually get something that's called a mortgage. Okay? So when you buy a house, you get something called a mortgage. And mortgage is a word that means a loan to buy a house. Okay? So in a mortgage, it's a loan that you get to buy a house. Okay? And so that's what mortgage means. Okay? And so when you have a mortgage and you buy a house, what you pay every month is you're not paying rent. You're doing something called a mortgage payment, okay? A mortgage payment, okay? Now, a mortgage payment is the payment for the loan for your house, and a mortgage payment is made up of two parts, okay? The mortgage payment is made up of interest and principal. Okay? So a really easy way to think about interest and principal is interest are the bank fees, okay? Bank fees, and the principal is what you owe. okay? So let's do, anyway, sorry, I'm trying to process here and think about what else you might need to know. Now, it is a little bit more complicated than this. That's not everything that there is to know, but I'm just trying to keep it as basic as possible, okay? When you go to buy a house and you go to the bank and you ask the bank for a home loan or for a mortgage, okay, the bank is not doing that for free. The bank needs to be making money off of you in the form of, pardon me, the interest that they charge you, okay? They're not a nonprofit. They are for profit. The bank wants to make money off of you. And in this instance, that's okay, all right? And so the interest that the bank is charging you, that's the money that they're making off of you for the home mortgage, okay? And then the principal is you actually paying back the money that you owe them, okay? So let's go back to the original example, okay? So if we're doing rent at $1,000 a month, $1,000 a month, okay? And that gives us rent at $12,000 per year, okay? All right, so this is all money when you're paying rent. This is money that you're never going to see again. Never see again. Okay? Now, when we're having a mortgage, though, that is completely different, okay? So if we have a mortgage, okay, let's pretend for a second that the mortgage payment is exactly the same as rent, okay? Now, oftentimes what you'll find is that the mortgage payment for a house or an apartment is actually less than what you'd pay in rent, believe it or not. So often, kids, buying a house, if you can afford it, is actually cheaper than renting. Again, believe it or not, okay? So let's say that your mortgage payment is also $1,000 a month, okay? And let's say out of that mortgage payment every month, okay, let's say that $300, okay, is interest, and $700, whoops, what happened? Let me scroll down, okay, $300 is interest, and $700 is principal, or paying back what you owe, okay? So kids, out of your mortgage payment of $1,000 a month, this interest payment you're never going to see again, okay? So the interest you're never seeing again, okay? This goes away, okay? That interest payment, poof, it's gone, okay? But this principal, okay? This principal, I should do that in green because green's like a good color for this, okay? This principal you're going to see again, okay? That $700 a month in principal, that's money that you now own in the house, okay? So the bank owns part of the house and you own part of the house, okay? And so that $700 that you're paying every month, you now own $700 more of the house on the mortgage, okay? And that leads us to our first, or our second word. So our first vocabulary word for the day. So for our vocab words, our first vocab word is mortgage, okay, and we already went over that. And our second vocab word is equity. Equity. And equity is the portion of the home that you own. From making mortgage payments but wait, there's more, okay? If you buy a car, cars become less valuable over time, okay? Buying a 10-year-old car today, you're going to pay less than what the car was 10 years ago, okay? Homes are the opposite. Typically, not always, okay, but usually homes and other buildings actually become more valuable over time, okay? So what a home costs today is actually going to be more than what a home cost 10 years ago. So equity is the portion of the home that you own from making mortgage payments and the value that the home has increased since you bought it, okay? So equity is the portion of the home that you own from making mortgage payments plus the amount the house has appreciated. And appreciated is a fancy way of saying gone up in value since you bought it. Okay? So, the equity on the house is the portion of the house that you own. Okay? So, if you're renting the house, at the end of the year, you pay $12,000 that you will never, ever see again. Okay? If you purchase the house, though, and you're paying a mortgage, this $700 every month in principal, okay, you're going to see again. And there's 12 months out of the year. So we take 700 and we multiply it by 12. Okay? It gives us what? 14, right? 7 times 1, 8,400. Okay? So every year, you're going to see, so we know there's 8,000, sorry guys, maybe I should have thought this through better when I was writing it out. So at the end of the year, okay, $8,400, $8,400 you keep, okay? So you're actually keeping $8,400 a year out of that $12,000 plus any appreciation. Okay? So the first thing I want to encourage you kids to do from this life skills set is I want to encourage you to one day buy a house. Okay? We were talking about generational wealth in the past. We talked about how to accumulate generational wealth. And one of the best ways to accumulate wealth for you and your family is to own your own home, because then you start creating equity in that home and you actually own that home. And one day, if you sell that home, you're going to see all that money again. You're not just spending money in rent and then having that money go away. Okay? And so we are going to be talking about different things over the course of this next week about homes. And buying a home is not always easy, but I do want to kind of start planting the seeds in your head about how to go about doing this, okay, one day when you're older. And you don't have to be crazy old to buy a house. I bought my first house when I was, I think, 23 when I bought my first house. And I was just out of college, and I had, I think, my first or second full-time job, and I was able to get a nice little place, and it was actually cheaper than renting. Okay, and so I want to put you all on that track as well. And if it wasn't for a lot of the equity and the money that I was able to save from buying my first house over 12, 13 years ago, I may not have been able to even start Da Vinci Tree Academy, because I was able to make sure that I had a very solid financial footing for myself and for my family. And because I was able to do that, I was able to do other things, like do different nonprofits and eventually do the school. Okay, so again, today's lesson is buying a home has a lot of intrinsic value in it. You begin to create equity and by paying that mortgage. Okay. Tomorrow we'll be going over 2 other vocabulary words that are involved in buying a home to, again, kind of take you through this process. Thanks, guys. All right, so for for current events today, I wanted to take just a few minutes to talk about why this current recession that we're looking at might be significantly shorter than other recessions in the past. And it's actually very, very simple, okay? The answer is that this current recession is being caused specifically by a disease. It's not being caused by a problem in the economy. Normally, when we have a recession, it's being caused by some other kind of problem that's within the economy. We have an issue inside the economy, like the banks don't have enough money to be paying them out. In the Great Depression, we had an issue that Europe owed America money, and Germany owed Europe money. And so Germany was borrowing money from the United States to pay Europe. Europe was using that same money to pay America. And it was this weird circle. And it kind of like donked up the entire world. Okay. And so typically in a recession or depression, what we're seeing is we're seeing a problem inside the economy and the way the system works. And because of that problem with the way the system works, we go into recession or depression. And so in this case, the system is working great. The American economy and the world economy both are working very well. We're creating a lot of jobs. We're creating a lot of great new products. You know, we have new technology coming out every day. We have new things that we can try, new restaurants, new foods. Everything's going really well. But the one problem is this disease. And so there's a really good chance that we're going to recover much faster in this recession than other recessions in the past, because as soon as the disease is gone, everything can start going back to normal. Now, it's never just that easy, because if somebody loses their job and a company goes out of business, right, you can't just flick a switch and start it up again, right? But it is a lot faster to maybe restart a company that has been closed for a few months because of this disease and get that company going again, if it already exists, than it would be from starting from scratch. Okay, and so a lot of small businesses and a lot of companies right now, it's almost like when a bear goes into hibernation. These companies are going into hibernation. Their workers are furloughed for the time being, which basically means that they get time off without pay, okay? And the business is basically hibernating. And as soon as COVID-19 goes away, the business can wake up again and start being a business. And so because, again, this problem is not from inside the economy, the problem is a public health problem that's from outside the economy, this recession might be a very short one. It's very, very possible. So we can all hope that this recession is as short as possible, and it is something that we can just get over right away. And in a couple of years, it'll be something that we all remember, but that we don't worry about anymore. Okay? And so that's today's current events. Tomorrow, we're going to talk about the flip side, about why this recession might actually be a much longer recession than other recessions, because we don't know what's going to happen yet. It could be either way. Okay? So that's it for today's current events. Let's get into history. All right, so we are looking at American history right now. I apologize if you can hear in the background, like my son doing the little raps from Miss Martell's class, but he's doing his homework right now too. So anyway, today we are talking about the Second Industrial Revolution during the Gilded Age. So we talked at some length about the First Industrial Revolution and what that meant. Talked about like the Lowell girls and things like that in class. The Second Industrial Revolution really had to do with a couple key things. So one key thing was steel. Okay, there was a big advance in steel, something called, I believe it was like the Bessemer process. And that allowed us to make steel that was much stronger for much less. And so it was a cheap and efficient way to make steel. The second big change that led to the Second Industrial Revolution was the idea of what do you call it? Let me skip that one as I'm thinking out loud here. So another idea, we had steel, and then we had the railroad industry. The railroad industry was really key during this period of time because right after the Civil War was over, there was a big race to do what we called the Transcontinental Railroad. Okay, we wanted to connect the East and West Coast together by rail, and so you could take a train from all the way from Maine all the way to California. Okay, and so those were two big ideas in the Second Industrial Revolution. So this idea of having really cheap steel that we could use to build railroads and much faster mass transportation out of, and This second idea of just having this mass transportation available in a modern fashion that could move goods and people to the West Coast very quickly. And then so third, gosh, I really should have written this down. It was the idea of specialization of labor and working like on a conveyor belt. Like Henry Ford in the production of his cars really nailed this idea of everybody having their own spot on the conveyor belt and specializing the labor. So, person number 1 and 2 would do one part of the process. Person number 3 and 4 would do the next part. 4 and 5, or 5 and 6 would do the next part. And so, as the car would come down the conveyor belt, everybody would be doing the same thing, and they get really good at it, and it would make the process very quick and easy. And so it was industrialization and mobilization on a new level. Okay, and so we also see a bunch of other advances at this time. Alexander Graham Bell and the telephone is invented during this time, towards the end of the Gilded Age in the Second Industrial Revolution in I think it was 03. At Kitty Hawk, the Wright brothers invent the first airplane that's not using any kind of like lighter than air propellant, like the hot air balloons and the helium balloons before them. And so we see all of these innovations come out. Alexander Graham Bell invents the metal detector in a vain attempt to try to help Garfield. During the Second Industrial Revolution. Oh, I should explain that a little bit. Garfield and Bell knew each other, and so when Garfield was shot, he had a bullet lodged inside of him for a really long time. And so Bell almost went crazy trying to invent ways for science to save his life. And so in this process, he invented a very precise metal detector. He invented the world's first metal detector to try to figure out where the bullet was inside of him so they could very easily extract the bullet without killing him, right? James Garfield eventually died because of the infection that he received because, again, this was right before sterilization was a thing. And so during the Second Industrial Revolution, America adopted sterilization technology as well. And so we see a bunch of technologies being adopted during this time that lead us all the way into the First World War. And so kids, if you think about like the Civil War and where we were at with like still using horses, still having wooden boats that were just beginning to be replaced with ironclad ships. And if you think of World War I, where we have planes, trains, automobiles, automatic weapons, and things like that, the Second Industrial Revolution is how we got from one to the other through all of these different innovations. In fact, at the end of the Second Industrial Revolution, America developed the world's most brilliant set of railroads. Today, America in the year 2020 is still referred to as the North American Land Bridge because it's actually cheaper for people in Asia to ship things to the United States, put them on a train, go all the way across the United States, then put them back on a boat to get to Europe. It's cheaper for them to do that than to just sail straight from Asia to Europe, right? And so our train system in the United States is the best and most efficient in the world, and it was built during this time, and it was able to be built because of this Bessemer steel process, and this Bessemer steel process also led to not just transportation, but to amazing manufacturing discoveries by, again, people like Henry Ford. And then we had all these amazing new inventions like the telephone and, the metal detector and airplanes and all that cool stuff. And so that is kind of in a nutshell, the Second Industrial Revolution. I do want to mention that in class, the normal history book that we use, chapters 19, 20, and 21, really dive pretty deep into this era of time, and it doesn't chunk it out into like the Gilded Age in the same way that Khan Academy does. Now, Khan Academy does not do anywhere near as thorough a job going over everything from this period of time as our book does. Our book is much better, but we are going to just kind of glide through all this stuff using Khan Academy because it's easier to do online and it's a lot faster. But for those of you who are in my class next year, we will be touching on this stuff in quite a bit more depth. We are missing a lot here. by doing it this way. But that's okay. Again, we're doing it this way because we have to for now. But again, we are just really skimming the very top of the surface for this history stuff here. All right, so your homework for tonight is to watch the 10-minute video about the Second Industrial Revolution, where they talk a little bit more and re-explained some of the stuff that I already talked to you about and get into a little more depth on some other stuff. Okay? All right, see you tomorrow. All right, ladies and gentlemen, it is week 4, day number 2, and we are on literature. So, for last night, you were supposed to read The Adventures of Tom Sawyer, and you were supposed to read chapter number 2. Chapter number 2 is one of my favorite chapters of any book of all time. So, Tom Sawyer is in trouble. I keep on wanting to say Huckleberry Finn, but anyway, Huckleberry Finn's another character that you'll be getting to know later. So, Tom Sawyer, he's in trouble because the day before he was being mischievous and he got in that fight, right? And so he has to paint the fence. He has to whitewash the fence. And so he's there and it's a beautiful day outside and he's like, I hate this so much. And this is something I always wanted to do as a kid. He turns it around. So instead of him being in trouble, he convinces everyone else in the neighborhood that whitewashing this fence is incredible and it's just like the best thing in the world. And so he actually gets other kids to do his work for them, and they want to do the work so badly that they actually pay him to do it. And so he turns his he turns his discipline into this big attraction for all the neighborhood kids. And I just love that, and that just speaks volumes to like who this kid is. He's so delightfully like mischievous and super intelligent to be able to like spin a situation around like that. Well, anyway, tonight for your homework, you need to read the next chapter. So we're in chapter 3. That's week 4, day 2's homework. So read the chapter. Again, write down the definition of every one of the words at the bottom and go ahead and write them 5 times each. Okay, so you have to do definitions and 5 times each for each of these words so that you begin to learn some of the more advanced vocabulary that this book uses. Remember the words that are like the old-timey words, you don't have to do those. You only have to do the words that we still use today. Okay, let's get to it, and let's move on to our next subject. Back, we're on week 4, day number 2, and so today is pretty easy. We're going to be reading through the book together a little bit, and then you have 3 questions that you have to answer for your homework. Okay, and so yesterday we were reading about pressure. We were talking about fluids and gases. One thing I wanted to clarify before we go on any further today is that gases and liquids are very similar. And so normally when we talk about fluid and fluid pressure, we're thinking of like water, we're thinking of liquids, okay? But the principles of the way fluids work often also apply to gases, okay? Yesterday, as we were reading through, I think at the very end, I mentioned that one of the big difference between a liquid and a gas is that gases are much more compressible than liquids, right? And so you can compress a liquid to a much greater extent than a gas. But in other respects, liquids and gases act the same. And so when we talk about these rules about fluids, they often apply for both, again, liquids and gases. Okay, so let's go ahead and start reading today about fluid pressure all around. So hold your hand out in front of you, palm up. You are holding a weight equivalent to that of a washing machine. How can this be? You are surrounded by a fluid that presses down on you all the time. This fluid is the mixture of gases that makes up Earth's atmosphere. The pressure exerted by the air is usually referred to as air pressure or atmospheric pressure. Air exerts pressure because it has mass. You may forget that air has mass, but each cubic meter of air around you has a mass of about 1 kilogram. The force of gravity on this mass produces air pressure. The pressure from the weight of the air in the atmosphere is great because the atmosphere is over 100 kilometers high. Okay? Average air pressure at sea level is about 10.13 newtons per square centimeter. Think about a square measuring 1 centimeter by 1 centimeter on the palm of your hand. Air is pushing against that small square with a force of 10.13 newtons. The total surface area of your hand is probably 100 square centimeters. So the total force due to air pressure on your hand is about 1,000 newtons. Whew. Now, that may have gone totally over your head, but think about this for a second, okay? Think about how tall the sky is, okay? The sky goes up a long, long way, okay? So the sky and the atmosphere above us, between where we are on Earth and outer space, that atmosphere is, again, 100 kilometers high, okay? And everything in the atmosphere has mass, and it's all pressing down on you, okay? And so I think this picture kind of does a good job illustrating it, okay? So you can see the guy down there sitting on the grass, okay? Figure 4, the pressure within a fluid is the same at any given level and is exerted in all directions. So the pressure pushing down on your hand is the same as the pressure pushing up. That's why you don't feel any pressure at all. So when you hold out your hand, you don't actually feel the weight of a washing machine because your hand is also pushing out, okay? That's why in outer space, if you were floating around outer space and you took off your space helmet, your eyeballs would pop out, okay? Because your body is actually pressing out, okay? So the air is pressing in and your body is pressing out against it, okay? Excuse me, and because you and I are earthlings, we were raised on this planet, our species came to be on this planet, okay? It's natural for us, okay? Our bodies naturally are pushing out at this level of about 10.13 newtons per square centimeter, okay? Balanced pressures. How could your hand possibly support the weight of the atmosphere when you don't feel a thing? In a fluid that is not moving, pressure at a given point is exerted equally in all directions. Air is pushing down on the palm of your hand with 10.13 newtons per centimeter squared of pressure. It is also pushing up the back of your hand with the same 10.13 newtons per centimeter squared of pressure. These two pressures balance each other exactly. So why aren't you crushed even though the air pressure outside your body is so great? The reason again has to do with the balance of pressures. Pressure inside your body balances the air pressure outside your body. But where does the pressure inside your body come from? It comes from fluids within your body. Some parts of your body, such as your lungs, sinus cavities, and your inner ear, contain air. Other parts of your body, such as your cells and your blood, contain liquid. Oh, here, let's see. Are you still having trouble believing that air pressure around you is so high? Take a look at the metal container in figure 5. Okay, so we're looking at this metal container right here. When the can is filled with air, the pressure pushing out from within the can balances the pressure pushing in on the can. Okay, so inside the can, there's pressure pushing out, and then there's pressure pushing in on the can as well from the normal atmosphere. Okay. But when the air is removed from the can, there is no longer the same pressure pushing from within the can. The greater pressure outside the can crushes it, okay? And so do you see this little mechanical MacGyver device here, whatever that is, okay? That thing is sucking the air out of the can, and because the air is being sucked out of the can, the surrounding atmosphere crushes the can. Okay, because it no longer has that force inside of it pushing out. Okay? Variations in fluid pressure. Does the pressure of a fluid ever change? What happens to pressure as you move up to a higher elevation or down to the deeper depths within a fluid? Pressure and elevation. Have your ears ever popped as you rode up an elevator? Air pressure decreases as elevation increases. So the higher you get, like if you're going up Mount Lemon or something like that, the air pressure is actually going down. Remember that air pressure at a given point results from the weight of the air above that point. At higher elevations, there's less air above, and therefore there is less weight of air to support. And I think instinctually that kind of makes sense. okay? If you're on the bottom of a pool, you have the entire weight of all the water in that pool on top of you pushing down. But if you're floating towards the top of the pool, you have very little water above you, so there's not that much weight, okay? In the same way, air pressure works in that same way. If you're at sea level, there's more air on top of you, so there's more air pressure. If you're on top of a mountain, there's less air above you, so there's less air pressure because there's less of it pushing down on you. The fact that air pressure decreases as you move up in elevation explains why your ears pop. When the air pressure outside your body changes, the air pressure inside will adjust too, but more slowly. For a moment, the air pressure behind your eardrums is greater than the outside. Your body releases this pressure with a pop so that the pressures are once again balanced. Pressure and depth. Fluid pressure depends on depth. The pressure at 1 meter below the surface of a swimming pool is the same as the pressure 1 meter below the surface of a lake. But if you dive deeper into the water in either case, pressure becomes greater as you descend. The deeper you swim, the greater the pressure you feel. Water pressure increases as depth increases. As with air, you can think of water pressure being due to the weight of the water above a particular point. At greater depths, there is more water above that point, and therefore more weight to support. In addition, air in the atmosphere pushes down on the water. Therefore, the total pressure at a given point beneath the water results from the weight of the water plus the weight of the air above it. In the deepest parts of the ocean, the pressure is more than 1,000 times the air pressure you experience every day. So, if you look at this bottle right here, okay, this little hole in the bottle right there towards the top has less pressure because there's less water, okay? So let me do this. Ooh, look at that. I can zoom in, okay? So, this hole in the top there has less water above it. And because it has less water above it, there's less pressure on this hole in the top. The hole in the middle has more water above it, and so there's more pressure. The hole towards the bottom has pretty much the entire container of water on top of it, so it has the greatest pressure, okay? So we can even see the variation of pressure according to fluid depth just by looking at this little like a milk carton full of, or milk jug full of water by poking some holes in it, okay? Isn't that cool? I think that's kind of neat, but it kind of helps illustrate it, okay? All right, so ladies and gentlemen, make sure that you're doing your science homework. That's it for our lesson for today. Whoops. All right, let's go ahead and get started here. How do I take this away? Oh, there we go. I can move that. All right, so group number 1, we are on week 4, day number 2, and we are doing a 2-day lesson, or actually I think it's a 3-day lesson on, as you can see right over there, the volume of prisms and cylinders, okay? And so let's talk about volume for a second, okay? So volume. When we're measuring volume, the easiest way to think about it is you can think about a fish tank or an aquarium, okay? So if you go to the store and you buy an aquarium to put some fish in, or maybe you have another pet or something that you want to put in this aquarium, okay? The volume of the aquarium is how much water you can place in it, okay? And so volume is how much water would fit inside this aquarium, okay? If you fill it up all the way, okay? And so volume is the measurement of everything that's inside of a three-dimensional shape, okay? So let's start reading through the book here, the volume of prisms and cylinders. So any solid figure can be any solid figure can be filled completely with congruent cubes and parts of cubes. The volume of a solid is the number of cubes it can hold. Each cube represents a unit of measurement called a cubic unit, okay? And so we've talked about cubic units already. When we have something like, if we have inches squared, what inches squared is measuring is 1 inch, okay? So let's say that this is 1 inch, okay, by another 1 inch, okay? So 1 inch by 1 inch, and it makes a square. Okay? And so this is an inch squared, just like that. Okay? Now, if we're talking cubic inches, inches cubed, then we have to have 3 dimensions. Okay? So we would actually have a cube, and each side of the cube would be 1 inch. Okay? I'm really having some trouble drawing right now. Okay? So imagine that that's a perfect cube. So we have 1 inch here. Okay? 1 inch here, and 1 inch here. So if we had a perfect cube with 1 inch on each side, it would be inches cubed, or inches with that little 3 above it. Okay? All right, so we call those cubic units, or in this case, it would be a cubic inch. Okay? Just like that. Okay? So these cubic units are units cubed with the little 3 on there. Okay? So, using cubes to find the volume of a rectangular prism. Find out how many cubes this prism holds, then give the prism's volume. Okay? And so we can just take a look at this prism here, get really close, and we can count up the cubes. And so we have this front face of cubes right here, and we have 1, 2, 3, 4. 1, 2, 3, 4. So 4 and 4 is 8. And then we have a row in the back. So if there's 8 in the front, there should be 8 in the back, and that gives us a total of 16 units cubed. Okay? So there's 16 cubes in this unit. Okay? And what they did right here is they multiplied 2, 4, and 2. Okay? So they said, all right, so the up and down right here, it's 2 units high, it's 4 units long, and it's 2 units deep. So it's 2 units high times the 4 units long, that's 8, times the 2 units deep right here, that gives you 16. Okay? So you can either just count the cubes, or you can do the multiplication using the measurements. All right? A cube that measures 1 centimeter on each side represents 1 cubic centimeter of volume. Suppose the cubes in the prism in example 1 measure 1 centimeter on each side. The volume of the prism would be 16 centimeters cubed. Okay? And again, just like I showed you down here with my cubic inch, this is a cubic centimeter right here. Okay? This volume is found by multiplying the prism's length times its width times its height. Okay? So again, we multiply the 4 times the 2 deep times the 2 tall, and we get the total cube. Okay? Now, when we're doing squared units, we're multiplying 2 things. Okay? When we're doing cubic units, we're multiplying 3 things. So as you're going through and you're doing this work, it's 3-dimensional, okay? And because it's 3-dimensional, it's 3D, you need to multiply 3 numbers together, okay? So if you're only multiplying 2 numbers, you're not doing it correctly. Notice that for the rectangular prism, the volume is found by multiplying the area of its base times its height. This method can be used for finding the volume of any prism, okay? All right, so far so good, okay? Now, for your Khan Academy work today, we're going to be working with exactly this. We're going to be doing rectangular prisms and finding the volume in the rectangular prism. Okay, this is a multi-day lesson. Tomorrow we're going to be moving on to finding the volume of something like a prism like this. In fact, let me pause the video for a second and double check. I think we're doing that tomorrow, but let me make sure we're not supposed to do it today. All right, so I just checked, and that's it for today. Okay, you don't need to do anything else for today. We're just focusing on rectangular prisms and cubes. And so go ahead and take a look at that Khan Academy stuff, and let's get that done. And tomorrow we're going to learn about this right here, about the doing triangular prisms and doing cylinders and the volume of other things like that. It is more complicated, so we're saving that for tomorrow's lesson. All right, thanks. Okay, let's go ahead and get started here. As you can see, we are on week 4, day 2 for group number 2. And so today what we are going to begin learning is solving systems of inequalities. So, ladies and gentlemen, we just finished solving systems of equations, and now we're moving on to systems of inequalities, okay? And so this lesson begins on week 4, day 2, and we are going to go all the way on this until week 4, day 5, okay? So we are doing this for the rest of the week. So I'm going to give you an example here. For today, what we are going to do is we are simply seeing the systems of inequalities, and then we are doing a review. So today, we are reviewing inequalities, just how to do inequalities in general. And then tomorrow, we are learning systems, okay? And then on the 4th day, we are going to be doing systems. Okay, so we're actually going to be working on doing the work. And then the last day we have a PDF to work on together. Okay, so that's kind of the schedule moving forward. Okay, so a system of linear inequalities is just like a system of equations. All right, so I have to have my bracket just like I did before, and I'm going to do an example system for you today, and then I'm going to leave you to do the rest of the review on Khan Academy. Okay, so we have y is less than 2, x is greater than or equal to -1, and then we have y is greater than x minus 2. Okay, all right, and so now we have to graph this here. Okay, so I'm going to take my graph with my x and my y. Does that give me enough room? It probably doesn't here. Let me go back and try to redo this. Sorry for the delay. Okay, here we go. Let's make that a little smaller here in just a second. Okay, I'll go blue for this first one. Okay, and so I'm at y is less than 2. Okay, so I have to go 1, 2, and I'm going to go out maybe 4 on each. 3, 4, 5. No, let's do 5. 1, 2, 3, 4, and 5. Whoops. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay, perfect. And I'll use green for this first one here. So we're going to have a line at y2. Okay, now as we can see here, this right here, okay, oops, this right here, that is not an equal to. Okay, so because it's not equal to, we need to make sure that our line is dotted. So I'm going to go ahead and dot this line here by erasing little bits. Okay, this is kind of a silly way to do it, but hey, it works. Okay, there we go. So I have that dotted line there. Let's do the next one in yellow. Oh, wait. So we know that y is less than 2. Okay, so we know that on this line it's going to be going down. Okay, so we know the shaded area for this area is down here, like that. Okay? All right, so let's do the one in yellow now, the next one. So we have x is greater than or equal to a -1. Okay? So I have to go to -1 on the x-axis, and it is equal to, okay, right there. Okay, so it's going to be a solid line. And so we're going to draw a solid line here, going through a -1. Good. And it's greater than. So we know it's going to be on this side. Okay. So we're going to shade in this area here. Okay. There we go. And then we have our third one, which is y is greater than x minus 2. So it's already in y equals mx plus b format. So we know it's going to be a slope of 1 over 1. And it's going to cross the y-axis at 2, or -2. Okay, so we'll go -2 here. There we go, -1, or 1, -1, and then 2, 0. And it's going to be a dotted line. Okay. Okay, let's see here. Here we go. There we go. I dot my line. Very good. Okay. And now because this is y equals mx plus b, we don't know, so we have to do a test for which side it'll live on. Okay. Or it'll live on. What am I saying? We need to do a test for which side is shaded in. Okay. And so I am going to use the dot at 3, 0, okay, as my first test. Okay, and then I'm going to use a dot at 0, 0 for my second test. Okay, and so we need to figure out which one is the solution. So actually, I only really need to do one test. If one test works, then the other one won't work. And so let me go ahead, I'll just erase this one because 0, 0 is by far the easiest. Okay. Okay, there we go. All right, and this is in red. Okay, so 0, 0, so I do y is greater than x minus 2, and we plug in 0 for y and 0 for x, okay? And we get 0 is greater than negative 2, okay? So that means that 0, 0 is our big winner right here, ding, 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 okay? And so that means the side that it's on 0, 0 is the actual side that is shaded, okay? All right, so if we look at this here, the part of the graph that meets all of our shading, okay, so it goes right here, okay, and then on this graph right here, we have this end right here, and then on this green part right here, we have this end right here, okay? So all three colors combine in this triangle, okay? And so when we graph this triangle right here is the graphed area, and so the answer can live anywhere within this triangle, okay? So this system of inequalities, the answer can be anywhere within this triangle because all three inequalities are colored in right in this area. And so it looks like a horrendous mess, but this is the basics of how this works, okay? And so again, for the rest of today, all I need you to do is do the review of inequalities. You're going to be taking the quizzes on inequalities to review. I think there's 2 links. And if you don't remember how to do those, you need to go back and take a look at the lessons on Khan Academy. We will pick up with this lesson tomorrow and get on to the next step by doing another example. Thank you very much.